In this video, we'll talk about combinations. Combination formula is combination of n taken k times equals n factorial over k factorial times n minus k factorial. Another thing that is important is that order doesn't count. Let's solve a few problems. Example 1. Find combination of 100 taken 97 times. So combination of n taken k times equals n factorial over k factorial times n minus k factorial. So in this case, combinations of 100 taken 97 times, also it can be written combination of 100 taken 97 times like that, is going to equal to, well, comparing the formula with the problem, we notice that n equals 100 and k equals 97. So we are going to replace them in formula for n factorial, so 100 factorial, over 97 factorial times 100 minus 97 factorial. So the first thing that I'm going to do is I'm going to calculate the subtraction, which is 3 factorial. So we have 100 factorial over 97 factorial times 3 factorial. So we notice, or we know that 100 factorial means 1 times 2 times 3 times all the way to 100. So I can write that 1 times 2 times 3, but it's going to take a long time to write everything to 100. So I'm going to write a few more, like 95, 96, 97, 98, 99 times 100. So this is what 100 factorial means, the product of all consecutive numbers from 1 to 100. 97 factorial means 1 times 2 times 3 times dot 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 times 97 and times, so this is 97 factorial and 3 factorial is 1 times 2 times 3. So we notice that all these numbers cancel with all these. So we end up with 98 times 99 times 100 over 1 times 2 times 3, which is 6. And we can do the math and we get 161,700. So another way we could have solved this specific problem was 100 factorial over 97 factorial times 3 factorial. So from this step on, instead of 100 factorial, we can write the smaller number, so it's 97 factorial times 98, 99, 100 over 97 factorial times 1 times 2 times 3, which is 6. So these two cancel and we end up with the same thing that we did before, 161,700. So when we have larger numbers, instead of writing all the product out, we can use to write 1 factorial, usually the larger one, in terms of the smaller one. So 97, it's used to denote or to write out 100 factorial. Example 2. In how many ways can one choose 2 Democrats and 3 Republicans from 8 Democrats and 10 Republicans? Well, first, let's find out how can we choose 2 Democrats from 8 Democrats. So since the order doesn't count, it doesn't count because it's just 2 Democrats. It doesn't necessarily, there is no rank, like one has to be president and one vice president, or one has to be a senior or one has to be a junior. You know, it doesn't matter. There is no restriction. So because of that, order doesn't matter. So we say combination of 8 taken 2 times equals, using the formula, it's 8 factorial over 2 factorial times 8 minus 2 factorial. So doing the math, we get 8 factorial over 2 factorial times 6 factorial. So 8 factorial, I'm going to write it in terms of 6 factorial. So it's 6 factorial times 7 times 8. 2 factorial, it's 1 times 2. And 6 factorial, I'm going to keep it 6 factorial. This cancels with this, and we get 56 over 2, which is 28. Now let's find out in how many ways can we choose 3 Republicans from 10 Republicans. So again, there is no restriction, so its order doesn't matter. So combination of 10 taken 3 times, using the formula, is 10 factorial over 3 factorial times 10 minus 3 factorial. So we get 10 factorial over 3 factorial times 7 factorial. I'm going to write 10 factorial as 7 factorial times 8 times 9 times 10 over 3 factorial is 1 times 2 times 3 and then times 7 factorial. So factorials cancel because 7 factorial divided by 7 factorial is 1. So we end up with 720 over 6, which is 120. So now to answer the question, in how many ways can one choose 2 Democrats and 3 Republicans, we are going to use fundamental counting theory principle, which says combination of 8 taken 2 times times combination of 10 taken 3 times. It's exactly the answers that we just got. 28 times 1, 20, and is 3,360. Example 3. Well, using example 2, we want to find the probability of choosing 2 Democrats and 3 Republicans from 8 Democrats and 10 Republicans. So the probability of choosing 2 Democrats and 3 Republicans is given by the number of ways to choose 3 Democrats and 3 Republicans. To choose 2 Democrats and 3 Republicans over the total number of possibilities. So let's find out the total number of possibilities. Let's do the denominator first. So combination of, well, how many people we have in total? We have 8 Democrats and 10 Republicans. That makes it 18. And then taken, well, how many we want to take? We want to take 2 Democrats and 3 Republicans. So 5. So the denominator, the total number of possibilities, is combination of 18 taken 5 times, which is 18 factorial over 5 factorial times 13 factorial, because it's 18 minus 5. So 18 factorial, we write it in terms of 13 factorial. So 13 times 14 times 15 times 16 times 17 times 18 over 13 factorial. And then 5 factorial, it's 1 times 2 times 3 times 4 times 5. So we can simplify this. We can, for example, 3 times 5, it's 15, so it cancels with that. 2 and 4, 2 times 4, it's 8, cancels with this, and we get 2. So we get 14 times 2 times 17 times 18. That is 8,568. So we found the denominator. So in our problem, to find the probability, we go equals 8,568, and the number of ways to choose 2 Democrats and 3 Republicans from 8 Democrats and 10 Republicans, we just did that above, and that is 3,360, and we can simplify this. Both numbers can be divided by 2, and then we can also notice, and then we can keep divide until we can simplify to the lowest term, but the simplest form is 20 over 51, because both of these two numbers can be divided by 168. So if we divide by 168, we get 20 over 51, or if we round to 3 decimals, 0.392, and this is the probability. Keep in mind, the probability, it's always a number between 0 and 1, or between 0 and 100%. And this is using the combination formula problem.